to review my assignment on ML Foundation, which is in collaboration with Duke University. Now, this is a peer-graded assignment, and the agenda for this project is to build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. Now, we have around 9,500 hourly average ambient environmental readings from the sensors at the power plant, which we will use in our model. Now, the four variables, the ambient variables are the temperature, the ambient pressure, relative humidity, exhaust vacuum, and our target output, which is the net hourly electrical energy output, PE, which we are going to see in our model. Now, grading criteria for this assignment would be the PR. Ideally would evaluate the video presentation, the one which I'm now making. With respect to these four approaches, one is the modeling approach. Did I correctly identify the type of modeling tasks, the features to use, and the possible algorithms to use? Building the model, did I compare at least two different models while building the model? Evaluating the model, did I use a reasonable evaluation metric for that? And interpretation of the model, did I correctly interpret and clearly communicate the performance of the model and the output? Now, for this, to get the working going, I will be using the CRISP DM framework. Now, this has been discussed throughout our course, which is a cross-industry standard process for data mining. Now, it starts with understanding the business problem, understanding the project, then the data, understanding the data that we have, preparing the data into the training data, into the model data and the output data, and then modeling itself, which will be done in Excel, then evaluating the output of the models and selecting the model that we want to go forward with and deploying it. Now, coming to number one, which is the business understanding. Now, we run a combined cycle power plant that uses a combination of gas, steam, and heat recovery to generate electric power. It is basically a combined cycle power plant for to generate heat engines, and they work in tandem from the same source of heat, converting it into mechanical energy. Now we have environmental readings from the sensors at the power plants, and essentially we want to identify which weather conditions create the most optimal electrical energy generation. And this will help us to optimize the plant and also to forecast and plan the responses to varying environmental conditions, which affect the output generation, and having that correlation between the weather and how much energy we can expect from the plant as an output. Next, we begin with a better understanding of the data. We see that the data is discrete, continuous, and structured. It contains four features, and the target feature is PE, which is our net hourly electrical output. And we have around 9,500 observations to train them for the overall training and testing of the model. Now we can also create a quick scatter plot in Excel to understand or begin understanding at a high level the correlations between the different parameters, the features, and our output. um, from these four graphs, we see that there's a strong correlation between temperature and the exhaust vacuum to the energy output. So this may be good features to start with. Next, we start preparing our data. As I have divided the data into three subsets. One is the training data. 70% of the data, or around 6,700, are taken for training. Around 15% for validation, around 1,400 observations, and again another 15% for testing the model output, which is again around 1,400 observations. Now, going into the modeling approach, since we are provided with a selection of four features, it would make sense for us to use a supervised learning parametric algorithm. Now, as we have learned from the course that a linear regression model is a great place to start with anything that is supervised learning. So we'll compare the three linear regression questions in Excel consisting of two, three, and all the four features. And more than one feature, we will use multiple regressions modeled by the equation output equals our bias plus the weight one feature and so on. Now, moving on to the model validation and the selection. For that, I have decided to use the MAPE, mean absolute percentage error, due to its interpretability, and alternatives. I have considered mean square error and root mean square error as they provide a fantastic evaluation. Now, the output of the model results are something like this. Let me jump into the Excel for this really quick. So we start with our data set provided. We divide the data. We divide the data into subsets. As mentioned, it would be around 70, 15, 15. It comes out to 6,698 observations for our test data. I just started at the top and took the first 6,700. We have model 1 training, model 2 training, model 3 training, and to gauge the absolute percent error, we take our residual divided by the output. So the residual from our predicted versus the actual, we get the average that number, which for this model led us to a 0.79% average percent error, mean square error of 20, and root mean error square of 4.5. And onto our validation set and final to our test data. um, we take our algorithm and deploy it here, calculate our residual and our absolute percent error. So from our matrix, we can see the model 2 and 3 have outperformed model 1 with an average percentage error of around 79%. We also notice the model 2 and 3 are nearly identical in terms of accuracy. That doesn't necessarily apply or mean to this exercise since this data is generally manageable. It's a small data set, but if it was a much bigger data set and model, I would prefer to select model number 2 in order to alleviate some of the computing power needed. And so my selection would be deployment model 2. Now I did take this uh, so yeah, deployment model 2. Now for reliability, to test the linear regression model against a random forest algorithm, I realized that Excel does not support this function. Thus, this thus this exercise is limited to finding this deployment model, which is my model number 2. So thank you for your time, and thank you for your evaluation.